In the summer of 1977, a spacecraft no larger than a small car began a journey that would become one of the greatest exploration missions in human history. That spacecraft was Voyager 2. Built with technology far less powerful than the devices we carry in our pockets today, it was designed to explore the outer planets and send back information about worlds that had never been seen up close. Few people imagined that nearly half a century later, Voyager 2 would still be traveling through space, continuing to communicate with Earth from unimaginable distances. Yet the spacecraft remains active, serving as humanity's eyes and ears in a region of space that no previous mission had ever explored directly. Voyager 2 was launched on August 20, 1977, from Earth with a clear objective. Scientists wanted to take advantage of a rare planetary alignment that occurs only once every 176 years. This alignment allowed a spacecraft to use the gravity of multiple planets as a series of natural slingshots, gaining speed and changing direction without using large amounts of fuel. The mission exceeded expectations almost immediately. As Voyager 2 traveled outward, it encountered 4 giant planets: Jupiter, Saturn, Uranus, and Neptune. Along the way, it captured breathtaking images and gathered scientific data that transformed our understanding of the solar system. At Jupiter, the spacecraft observed powerful storms, volcanic activity on the moon Io, and complex magnetic fields surrounding the planet. At Saturn, it studied the planet's rings in extraordinary detail and revealed new information about its many moons. The journey continued even farther. Voyager 2 became the first and only spacecraft ever to visit Uranus and Neptune. It discovered new moons, observed unusual weather systems, and revealed features that scientists had never expected to find. By the time it completed its planetary tour, Voyager 2 had already secured its place in history. But its greatest adventure was still ahead. Beyond Neptune lies a vast and mysterious region where the influence of the Sun gradually weakens. Although sunlight continues far into space, the solar wind, a constant stream of charged particles flowing outward from the Sun, does not extend forever. Instead, it creates an enormous bubble surrounding the solar system. This bubble is known as the heliosphere. For decades, scientists believed the heliosphere acted as a protective shield, helping to block some of the high-energy particles that travel through the galaxy. However, many questions remained unanswered. How large was this bubble? What happened at its outer boundary? And what existed beyond it? Voyager 2 was heading toward the answers. Year after year, the spacecraft traveled farther from Earth. The distance became so great that radio signals required many hours to cross the void between the spacecraft and mission controllers. Even a simple command took a long time to reach its destination. Despite these challenges, Voyager 2 continued operating. Then, in 2018, the spacecraft reached a historic milestone. Its instruments detected major changes in the surrounding environment. The solar wind dropped dramatically. Cosmic rays from deep space increased. Measurements of plasma and magnetic fields revealed that Voyager 2 had crossed the heliopause, the outer boundary of the heliosphere. For the first time, humanity had direct measurements from interstellar space. The crossing provided scientists with a unique opportunity to compare conditions inside and outside the Sun's protective bubble. The results confirmed that the heliopause is a distinct boundary where the influence of our star gives way to the broader environment of the Milky Way galaxy. This discovery was significant because it demonstrated that our solar system is not isolated. Instead, it exists within a constantly changing galactic environment filled with energetic particles, magnetic fields, and streams of plasma. Voyager 2's measurements also helped researchers better understand how the heliosphere protects Earth and the other planets. By reducing the number of high-energy cosmic rays that reach the inner solar system, this enormous bubble may play an important role in shaping conditions throughout our cosmic neighborhood. Yet interstellar space proved to be far from empty. The spacecraft detected variations in particle density and magnetic activity, revealing a region filled with dynamic processes. Instead of a silent void, scientists found evidence of a complex environment influenced by events occurring across vast distances of space. Exploding stars, stellar winds from distant suns, and large-scale galactic magnetic fields all contribute to the conditions Voyager 2 now experiences. Another fascinating discovery involved magnetic fields near the heliopause. Researchers found that the magnetic field beyond the heliosphere appeared more closely aligned with the Sun's magnetic field than many models had predicted. This unexpected result sparked new investigations into how the heliosphere interacts with the surrounding galaxy. Every piece of information transmitted by Voyager 2 helps scientists refine their understanding of the region beyond the solar system. What makes these achievements even more remarkable is the age of the spacecraft itself. Voyager 2 was built during an era when computers had only a tiny fraction of the processing power available today. Engineers could not update its hardware after launch. Everything had to work reliably for years in an environment of extreme cold, radiation, and isolation. To keep the spacecraft operating, mission teams have carefully managed its limited power supply. Over time, some instruments have been turned off to conserve energy. Engineers continue to develop creative solutions that extend the mission and allow Voyager 2 to keep sending data home. Each signal received from the spacecraft represents an extraordinary triumph of human ingenuity. Attached to Voyager 2 is one of the most famous artifacts ever sent into space, the Golden Record. Created as a time capsule for the cosmos, the record contains sounds, music, greetings, and images intended to represent life on Earth. It includes recordings of nature, human voices, and selections of music from different cultures around the world. The Golden Record was never expected to be found. Instead, it serves as a symbol of curiosity, exploration, and hope. Long after Voyager 2's instruments stop functioning, the spacecraft will continue its silent journey through the Milky Way. It may travel for millions of years, passing through regions of space that no human will ever see directly. Although contact with Earth will eventually end, Voyager 2's legacy is secure. It transformed our understanding of the outer planets. It became the only spacecraft to visit Uranus and Neptune. It crossed into interstellar space and provided humanity's first direct measurements from beyond the heliosphere. Most importantly, it demonstrated what can happen when curiosity drives exploration. Today, Voyager 2 continues moving farther into the darkness between the stars. Every kilometer it travels takes it deeper into a frontier that remains largely unexplored. Its journey reminds us that even the most distant destinations can be reached through patience, innovation, and determination. As humanity looks toward future missions to the Moon, Mars, and beyond, Voyager 2 remains a powerful symbol of discovery, a small spacecraft carrying the story of our world into the vast expanse of the galaxy, one signal at a time.